Okay, so this chart right here goes through factoring. It's kind of a flow chart that you can use when you're factoring. So every time that you factor, you always want to see if there's a greatest common factor. Every time, whether it's 2 terms, 3 terms, 4 terms, 5 terms, you need to look to see if you can divide something else out. So if it's a greatest common factor, then factor it out. Then, if no, then you can't factor it. Then you have to look at how many terms there are. Are there 2, 3, or 4 terms? So if there are 2 terms, do you have an a squared minus b squared situation? In other words, can you take the square root of each of them and get an expression that doesn't have a decimal in it? Or I mean, I guess it could be a fraction. So if you had, for example, 1/4 x squared minus 9y squared. You can take the square root of both of these, and notice difference of squares is a squared minus b squared, so it's going to turn into a plus b, a minus b. So this would be 1/2 x plus 3y, and then 1/2 x minus 3y. The signs have to be different, opposites, in order for this to be a negative. And is it a trinomial? Does it have 3 terms? So if it has 3 terms, check to see if it's perfect square. So this is the formula for a perfect square right here, and we're going to do that on the next page. And if it's not a perfect square, can you figure out if there are factors? If there's not a number out front of x squared, can you find factors of c that add up to b? Or if the number in front of x squared is a, can you do it by the grouping method? Do factors of a times c that add up to b, and factor by grouping. And if it has 4 terms, we're going to factor by grouping. But none of the next examples have 4 terms. So difference of squares we already talked about was a squared minus b squared, and that's going to factor out into a plus b, a minus b. Perfect square trinomials, what we're going to focus on today, that's when you have something like a plus b squared. This is the factored form. The original form looks like a squared plus 2ab plus b squared, and you can figure that out by FOILing. And you could also have a perfect square trinomial that has a minus b, and that's the same except for it's going to be a squared minus 2ab, but it's still going to be plus b squared, because negative b times negative b is a positive b squared. So on this first problem, I am noticing that there's not a greatest common factor. I can't divide all 3 by something, and it's not difference of squares. It has 3 terms. So I'm going to see if it's a perfect square trinomial. So in other words, can you take the square root of 49p squared? Yes, 7p, and this is going to be 5. And the 2ab is, if a is 7p and b is 5, if I multiply 2 times a times b, 2 times 7p times 5, do you get the middle one? You do. So we know it has to be a perfect square trinomial. So this is going to factor into 7p plus 5 squared, based on the formula up here. Okay, number 24. I try to do the greatest common factor. I can't. So then this is difference of squares right here. I can take the square root of this and the square root of this. So it's going to be 7n plus 6, 7n minus 6. And 25. I'm going to do the greatest common factor because I can divide both of these by 2. So it's 9n squared minus 4. Okay, then you still have to check what's next, or what's left. What's left is a binomial, and then I can check to see if it's difference of squares. So if I take the square root of 9n squared and 4, I'm going to get 2 times 3n plus 2, and then 3n minus 2. And then number 26, I'm going to do, all of three of these can be divided by 2. So this is b squared minus 14b plus 49. So because there's not a number in front of b squared, it's just 1. It isn't a number, but it's just the coefficient's 1. I'm going to see if I can find factors of 49 that add up to negative 14. So in this case, it's negative 7 and negative 7, which is a perfect square. So I can write it like this. Don't forget to keep your 2 on the outside of your answer. That's really important that you keep a 2. Because really, you could check all of these by foiling. You could foil these and then multiply it by 2 and you'll get the exact same answer. So this, if I foiled it, I need to get the exact same answer. And then 27, I want to find the greatest common factor. So what is a number that can divide all of these by? The highest number. So right now, I know I can divide them all by 2 because they're all even. I know I can divide them all by 3 because 54 is divisible by 3, 5 plus 4 is 9, that's divisible by 3, 7 plus 2 is 9, that's divisible by 3, and 24 is divisible by 3. So if you can divide a number by 2 and 3, that means it's automatically divisible by 6. So I know 6 has to be the highest number. It's not 12 because 54 doesn't go into 12. So I'm going to factor out a 6. So 72 divided by 6 is 12. So now I'm going to see if I can still factor out what is inside of here. So this is it's a perfect square trinomial. I think I'm going to check it though. I can take the square roots of the first term and last term. So in this case, A would be 3r and B would be 2. So if you multiply 2, because the formula is 2ab, 2 times 3r times 2, you get 12r. So it's going to be 3r plus 2 squared. Okay, 28, I can factor out a greatest common factor is 3. So it's 3 divided by 12, or 12 divided by 3 is 4, plus 4x plus 1. So I can take the square root of the first term and the last term. So in this case, a is equal to 2x and b is equal to 1. And when I multiply 2ab, I get 4x, so it works. So it's a perfect square trinomial, so it's 2x plus 1 squared. And you can always check it again by foiling this part and then multiplying everything through by 3. And this next one, let's see. I can divide them all by 5. Can I go anything higher than that? So 45, the factors are 15, 9, 5, 3. So I know that 5 is the highest so far. 5 is higher than 3, so I'm not going to count it. 9, to figure out if it's a number is divisible by 9, add up the digits and see if that number is divisible by 9. So I know it's not because 2 plus 1 is 3, and that doesn't work. So then 15, can you divide 210 by 15? 210 divided by 15 is 14, and 245 divided by 15, I don't think so. Nope. So the highest number is 5. So we're going to take a 5 out and do 9n squared. 210 divided by 5 is 42. And then 245 divided by 5 is 49. So you can take the square root of this, the first term and the last term, the A term and the C term, and get 3n and 7. And when you multiply 2 times 3n times 7, you get 42. And then it can be a negative 42 because it would be 5 times 3n minus 7. Because negative 7 times negative 7 is at positive 49. Negative 7 times 3n times 2 is negative 42n. So it works. And then the last one, big numbers. So is this, can I divide it by 9? No. So I'm thinking of factors of 54. 54 is 1, 54, 2 and 27, 6, 9. So I'm going to check to see if 294, if I can divide it by 27. I can't. So now I'm going to do 294 divided by, well, I know it's not going to divide it by 9, divided by 6. So I can divide them both by 6. So I do 6 times, this is 49, a squared minus 9. So in this case, I can take the square root of this and the square root of this. So it's going to be 6 times 7a plus 3 and 7a minus 3.